All right, we've dealt with what call this the shift register so far. We've looked at what? We've looked at the series, what called the shift left. We've looked at the shift right. We've done the shift left or shift right. All right, but then there's a little few things that I want to add now. Let's look at the different types. The different types that we have also. We have what I'll call the series in, series out. We've got also the series in, parallel out. We've got the parallel in, series out, and finally we've got the parallel in, parallel out. All right, so far we've been really looking at more or less the series in, series out, more or less. But let's look at what we've been dealing with so far. We've been dealing with, let's have 4. No, I don't like that shape. All right, let me try and be a little bit more. It's shift registers, so it is going to be D types or other configured as D type, configured to function as D type. All right, so all that will do is delay data and what, but just pass it through. All right, so now we've seen how we're having the input coming in through the one end, and coming out through the other end. For the in the case of what, of shift left and shift right, doesn't matter which one you choose, but for series in, series out, we would worry about the data shifting from one direction, that is a Q, from one direction to another, possibly. So either one, what am I doing? This is the, oh yes, what's wrong with me now? All right, now and then this is the Q. Probably talking and working at the same time is getting a little bit tricky. Now we've seen how primarily we've been dealing with D or other types that are configured as D. All right, so that our input, our series in, is simply our input coming in on the one end, series in, okay, and series out. So this is where we just take this is where we just take our input from one end and we glide it through, and then it comes out at the other end. All right, as redundant as they are, let's show the not use. It looks too naked, but basically the whole story has been told, except obviously we need a clock. So then it depends on whether we're using master slave or we're using we're using the latch type. So if we're using the master slave, we know there's going to be a thing here, but otherwise we might be using just a normal latch, a normal D latch. And I've been doing examples with the master slave, so there's no harm in showing that. The only difference there is that the response is going to be what? The only difference there is that the response is going to be on the leading edge. So difference here again, I'll put a reminder again. Difference here is how the clock is done. Is the clock done like the master slave way, so that we look at what? So that we look at the response coming from the trailing edge, or is it done there the other way, which is where we have our latch working with the leading edge. So the difference is that, so doesn't matter what I do here, as long as I know my response is going to be either leading edge, as with the example that I'm doing here, or if I done that, it's going to be the trailing edge. Okay, so now unless it's specified, both of them will work well. All right, so the applications is, if I want, remember what happens here, you want to put in data, and each clock pulse, let me rather note this down, not each, I said clock pulse, I rather meant to say each flip-flop delays the, what call this, the data by a clock pulse. But this is true in all instances, except the entry, the data entry one, which in the case of leading edge response. What do I mean here? In the case of leading edge response, all right. So what do I mean here? If we are working with this one, which works with the leading edge, remember that the delay for the first one will only be half the clock pulse. All right, the delay will only be half the what? The clock pulse, because this is only half the clock pulse to go to the leading edge. But if it's a what? If it's a trailing edge type, then, but even then, if all of them, like the subsequent ones, are still going to give us what? That's why I said only entry level. All right, the subsequent ones are still going to give us what? I've explained this before. It's going to give us a full clock pulse delay. Only the entry level one, the entry one, in this case this one here, it will delay by half in the case of the leading edge response. But in the case of what? Of a trailing edge response, all of them are going to delay by what? Are going to delay by 4 clock pulses. So if I wanted to delay data, if I wanted to send data through, and I wanted to delay by a certain number of clock pulses, if I wanted to send data through and I wanted to delay by a certain number of clock pulses, what I would do is I would use that many, what call this, number of flip-flops as well. If I want to delay by 3 clock pulses, I'll use 3 flip-flops. If I want to delay by 2 clock pulses, I'll use 2. If I want to delay by 1, I'll only use 1. All right. So if I want to delay by half a clock pulse, then in this case I'll use a flip-flop that uses what? That has leading edge response. All right, leading edge response. In that case, it's going to be what? Only half. This is what I mean here. All right. So series in, series out is very simple. The data comes in through the one end and comes out through the other. There is no parallel output. Okay, when you are dealing with series in, series out, we don't have a parallel outputs. The clock pulses keep what? We don't take out outputs from the what? From the queues in between. The first clock pulse we fit in, the last clock pulse we take out. All right. So if we're in this situation, if we want our data will only be complete, our data will only be complete after our data. Let me note this as well. Our data is complete after number of bits, after the number of clock pulses, the number of clock pulses that corresponds to number of data bits plus n minus 1, where n is the number of what do you call this, flip-flops used. Let's see what I mean there. Let's say my input has got 7 bits. That's a random example I'm picking there. All right, that's 7 bits. First bit will first clock pulse will allow the first bit to go through. Second one, third one, fourth one. So after 4 clock pulses, we've got 4 bits in. All right. Now the first bit appears after what? After the number of what of flip-flops used. Okay. So then after that, to complete that data to come out, you're going to need 3 more clock pulses. Why? 3 more clock pulses because when you're going to need 3 more just to complete the data to come out. All right. Because now I'm not sounding right. What I mean here is I've got 7 bits. So what I'm going to need is I'm going to need 7 bits for the what? For this data to finally be what? 7 clock pulses for this data to finally read the last 4. After 1 bit, I've got the 1. After 2, after 1 clock pulse, I've got the 1. After 2, I've got 1, 0. After 3, I've got 1, 0, 0. After 4, I've got 1, 0, 0, 1. Now this is after flock. So I've got the first part of my data coming out, but there's 4 flip-flops. So my first part of the data will come out after 4 clock pulses. For that data to totally be out, meaning that for the last one to totally be out, I'll be having what call this 3 more clock pulses. For this to move, there is 1, is 2, is 3. So for this bit that first dressed up the parallel outputs to come out, I need 3 more clock pulses. But I'm not done. I still have the other this 0, 1, 1 left. Okay, so after 7 bits, I've got my data out. Okay, this is what I meant here, that you're going to need what? The number of clock pulses that corresponds to the number of data bits. Okay, so I'll need 7 bits to come out. But to flash out the last one, I still need to do what? The number of what? The number of flip-flops minus 1 more time. So I still need to do the 4 flip-flops, and I still need 3 more times. The first time that 0 will come out at what? At the highest, at the output. Second one, that one will come out. Third one, so it was what? 3 more times, which is 1 less than what? The number of what? The number of flip-flops. So for our data to be complete, if we don't have the same number, if our database is not the same as the number of flip-flops, so for our data to be completely out, we need first of all to get 7 clock pulses. But that 7 clock pulses is not going to get our data out. What it's going to do is going to get the 4th one out in the case of 4. Okay, then you still need what? 3 more to get rid of what? Of the other one. All right, so that I hope is clear. So do you really need to fuss that much about that? That is a little bit extra thinking, a little bit extra reasoning. What you really need to understand here is that what? We've got a type that is what? Series in, series out, and the data comes in on the one end and simply flows through one by one. So it's 1 bit. So this actually is slower. It's slower. I'll come back to slow and fast. This is slower because each bit, every clock pulse, 1 bit comes out. Every clock pulse, 1 bit comes out. We'll come out to versions that are faster. You will see why we say they are faster. But for now, I may have forgotten to mention that we are talking about what? We are talking about a common clock here. I didn't indicate the clock. So if I want, so what do? You need to show me the what? Then remember, there's nothing wrong. It's just a little bit more difficult to draw a one that goes to the what? That goes to the other side. All right. In this case here, we don't really worry about. It's not really necessary because we didn't really worry about which is Q1, which is Q. This could be Q8, Q4, Q2, and Q1. In which case, it's going to be a shift right. Even though the diagram says shift left, but remember, in the actual sense, Q1 is what? Is actually on the what? On the right side. Okay. So this again could be Q8, Q4, Q2. So I didn't specify which Qs are, so it could be anyway. So this is the general scenario of where data comes in series and comes out in series. What you call the SISO. All right. All right. Then we have the option of what? I don't know whether I should continue on the same page now. Let me allow another page for me to what? To do the what? The SIPO. So see you next when you look at the SIPO. Ciao.